This is me the first time I heard about OpenRISC.
Yeah.
Yeah. So this presentation is not going to be about what OpenRISC is, or even try to explain what OpenRISC is. It's going to be about my experience from being a newbie to OpenRISC and what I saw and what I maybe think is missing and what is good. But before that, we have to go back a little bit in time because I have to explain why all this blogging started. So first I put up my timeline here. See, I've been 40 years now in this business. And I started out in '69 when I started my Master of Science Engineering. And at that time we used mechanical calculators and slide rule, and we programmed with punch cards. I joined Ericsson '74 and happened to be just by an accident, I moved into component testing and worked with component testers for 15 years almost. Before I realized that there was another world, and that was the ASIC design world. And at that time, Ericsson started to use ASICs in all their projects. And I moved in there and became an ASIC designer. I stayed at Ericsson until 2006, when they offered me a good package to leave, and I was a little bit tired after 30 years. I got my gold medal, so I felt I could leave now. And my idea then was to start my own company and work as a consultant with ASIC and FPGA design. And that wasn't so easy, I found out. Just the picture of 75, I just found this one. Look at the 50 kilo lighter version and the bell buttons. that was 75. So, what do you do if you have been an ASIC designer for 15 years and know nothing about FPGAs? Actually, I've seen FPGAs. I didn't know about them, but I haven't used them much. And starting as a consultant, I realized that I'm not going to do much ASIC work. If I'm going to do any work, it will be FPGAs probably. So I sat down there and tried to figure out how can I learn about FPGAs. And then I got this idea, why not just start from the beginning? Get one of the development boards and start experimenting and learn by doing. And at the same time, I don't know why, but there was at that time a lot of people talked about blogging. There were blogs for everything except for more for fashion and high life, not so much about ASIC design or FPGA design, but maybe you can write a blog about FPGAs too. So I started, and I called the blog FPGA Design from Scratch, and I managed to get that web address too. So how to do it then? Yeah, the main objection here was to learning by doing. That was the whole idea. I'm going to sit down and just going to start from the beginning and just going to go through everything and try to understand and build something, some real hardware, and try to find the information wherever I can find it. And at the same time document everything so it's easy to follow for everyone, even for a newbie. And of course, on the internet, you can spread the word all over the world. So that was great. And I also wanted to get some feedback from readers, of course. The blog is perfect because you can get questions and you can ask questions. Then of course the spammers find this, and that is just impossible. Have communication on blog. You get just all these silly spams. But in the beginning it was okay. So this is the first page on my blog. Started December 27th, 2006. And actually there are almost 100 parts in my blog in this, which I finished 2009. I worked with this blog until I got a real job, which comes later. Because then I didn't have much time. This was the 18 months I got paid from Ericsson and leaving. I could spend on this blog. Of course, you cannot live from writing blogs. That I found out after some time. But the good thing was that I had my company. It was called ZooCat Consulting, and I was waiting for finding some jobs. And I was blogging all. Then my wife told me, "This is not going to bring any food on the table. No, it's not going to do that." So, but one day, Johan called me and offered me a job. I think he had read my blog. At least, for some reason he found out that I maybe would be a person that could work for OpenRISC. So I was hired by OpenRISC, and my first project was this.
Looks good.
Can anyone guess what this is? I guess you have already heard from Johan's presentation. This is actually a floppy disk replacement. And that was ABB Robotics, or Sverov in Västerås, who asked us to design this. Just to replace the whole floppy disk drive with something that is compatible in the contact, the connection, which is not that easy as it may sound. You have the floppy disk rotating and giving a pulse every 300 kilohertz or something like that. So I started out with this design. I took an old PC and removed the floppy disk and connected my board, and that board had, of course, the OpenRISC as the controlling processor. I was sitting there trying out everything, and nothing worked. And until Michael came and said, "What about your asynchronous signals? What do you think about that? Are you really synchronizing them?" I've been an ASIC designer, designing a synchronous block inside an ASIC for 15 years. I haven't heard about asynchronous signals. So I've been sitting there trying out, worked, didn't work, worked, didn't work, worked, didn't work. So I gave this project to Michael, and he finished it. And this is actually what came out of it. And it's
works fine.
It works fine, and now it's even improved, and
now even better.
Yeah. But at least I came up with how to send display, how to send the data to display. No, I did a few things. I really figured out how things work, but
actually, you did everything except the asynchronous stuff.
Yeah, okay. That's good. Good to hear. So, next step. I worked for OpenRISC 3 years, 2 years. And then I moved over to real-time embedded. And here at real-time embedded, I was also had some spare time after leaving consultant work, and we decided to start a project called Modesty, or Core X, and where we're going to build a multi-processor system on an FPGA and try to figure out how to communicate between these processors. And in that same time, we thought maybe we start looking at the Leon 3 processor, which may be the one we're going to use. We haven't really decided. But I thought maybe we can look at some other processors, embedded processors. So I also picked up Microblaze, Neos 2, and OpenRISC 1200. And as I told Jesper, see you here, maybe we could write a blog about these processors. That's a good way of describing the work, and we can get some visitors to our website. Actually, the website, we have 300% more visitors to our website after I started writing this blog. So,
not surprised.
So yeah, I covered all this, but we leave out the concentrate on the OpenRISC today then. So I had to find a FPGA board. I could of course maybe have used one of the OR support, but then everything would have worked. So then it would be much to write about.
Right.
So I decided to, I looked at the OpenCourse website and also what Julius had done in the ORBSOC, where he had actually covered a few boards, or who did it. I don't know who did it, but
yes.
Stefan did. Okay, Stefan did. Yeah. Anyway, I picked out this board because it was Xilinx, and I have a lot of experience with Xilinx after using microarrays. And I thought it was a nice board. And yeah, it was a nice board, but it wasn't that easy to just run OpenRISC on it. But anyway, I started out in the beginning of this year, and yeah, it took 1 month to go through the whole process of figuring out how the board worked, how to use ORBSOC to synthesize and get the bit stream to program the FPGA. I also figured out that I need to run a simulator, and of course this latest Xilinx design suite. There is no model sim anymore, so I decided to use iSim, and of course that was not fully supported or not supported at all.
What is iSim?
That's the Xilinx simulator that comes now with the Xilinx design suite. Quite a good simulator actually, mixed Verilog VHDL.
Oh, really? Okay.
Yeah.
iSim
Yeah.
doesn't support VPI.
Yeah,
Oh,
okay.
really?
Yeah, okay.
Oh.
Yeah, there are things for experts, but for a simple newbie, it's good enough.
But did you use the free one that comes with it, or?
No. One good thing, because I had such a good relation with Xilinx, and company has too. So I can easily get the licenses.
Yeah, because I believe the free one is crippled. So
Yeah, that's
so
a silly thing.
Yeah.
That's what I don't like about Xilinx, that they cannot give away their design tools for free. They just try to get you to pay for everything, which is a little bit.
Hey, Xilinx gave you a board, right? After your initial blog series?
I mean, the problem is, I mean, I've done so much work for Xilinx here. I mean, a university in Canada called me and said, "Oh, we use your blog, and we switched from Altera. 100 people can now use Xilinx instead." I mean, but from Xilinx I got 2 boards for free. Probably I have to pay customs for that.
Oh, really?
That was all I got from Xilinx. So no, but as I said, you're not gonna be rich on writing blogs, but it's fun.
But you did get a job.
Yeah, I did get a job. That was the most important thing. That actually, and that's why I tell my wife all the time when she complains about me. So yeah, simulating, writing programs, programming the speed flash, installing U-boot, which is perfect. I mean, when that runs, you're up and running. You can do everything, because programming the flash through the FPGA takes forever. I mean, that's but when you have U-boot in the flash, and I have actually the board running in there now with U-boot and everything. And if you want to take a look, you can. I installed Linux, got it running, and of course I have to say thanks to Stefan, because I bombarded him with questions at that one time there, and I got answers back all the time. That's a good thing, being a newbie, knowing nothing, and you can ask questions, and you can find people that answer questions in this community, and that is probably the best thing about this community. Yeah, I did that. I also ran the benchmark, the core mark benchmark, which I did for all the 4 processors, comparing them. I mean, it's not easy to compare, but it gives a figure, and you can say that Microblaze Neos 2 and Leon 3 is a little bit faster than OpenRISC. But
I got a question about that. What kind of boards did you have? Did you have some same kind of setup with SD-RAM?
no, you can't say I have the same setup, but it was similar. I used Spartan. It was a Spartan 6 FPGA for Microblaze, but it was not the same board. But I mean, it's measuring mostly the processor. It's not so much measuring memory.
When you say faster, you mean the actual clock speed of the processor, not the application.
The core mark value was, I mean, was high. I mean, that is the value that you compare you divide by the megahertz. It's not.
Okay, yeah, okay. So you are factoring in the quality of the compilers as well.
Yeah, the compiler will probably everything that generates the program.
CoreMark's been developed to try and separate out the compiler optimization.
Yeah, okay.
So
I know, yeah, but
Of course it's kind of
It
but
depends
I
on-
ran with different optimization and measured different values for. I could see that. I mean, if you take 03 or 02, you can see the difference.
And what release of GCC was it between the different?
You have to look at the blog. I don't remember.
4.5.1 for OpenRISC.
Yes, I mean, but if you ran, you get a significant difference if you just ran 4.8 because there's no more optimizations in there.
Yeah.
So
No,
I think they were pretty much the same range.
Yeah,
Okay.
it's not so much that comparing the process. It was more a way of just having it running and see that it gave a value. And
I guess we're picking up on this because when people come and say, why should I use OpenRISC rather than one of the supplier things, actually knowing what the difference in performance is really quite an attractive part of the argument. And if you can say, well, OpenRISC is the same speed, or even better, OpenRISC is quicker, then some of the arguments against OpenRISC go away.
Yeah, but CoreMark is the program people use today to compare. I mean, you can go into the CoreMark's website and see all the processes there and compare them. But of course, the value is still just the value.
But at least you can say it's comparable. You have actual proof that.
Oh yeah, I'm saying it's a good start. I'm not
less,
criticising. Haven't got started on the issue.
I actually think that it's a good start to get it like more, let's say, faster, so that it gets actually a better core mark, and then use it as a marketing thing.
I think you can compare. I mean, it's good comparing just OpenRISC, the different GCC versions, and newer OpenRISC. There you can get a good comparison running on the same board. One thing I found out, building the tool chain, of course. I will come back to the complaints I have, but building tool chain was a mess, of course, until I found about Orbill and this guy, DS.
Ruben Diaz.
Yes, made a great job there.
Yeah.
When you start that run and it just produces millions of lines of things and it just makes files and you just sit there waiting, hopefully it's going to finish. And first time, of course, it failed somewhere. And that was, of course, something missing in the Ubuntu installation. But I managed to get everything fixed and run through and got the tool chain.
So why did you use OR build rather than the original build script? I mean, I'm not as interested because I wrote the original script. I think.
I didn't use the original build script. The first thing I did was I downloaded the finished build thing. I used that one because I wasn't interested in building the tool chain at all. But then when I read about Orbill and found out that this is just a push button on this thing, then I tried it and it worked. And I think he done a great job there. As much as I know. Okay, I also looked at ECOS, not knowing so much about real-time operating system. I just read what was there and got it up and running. So that was 1 month work there. That takes you from knowing nothing to knowing quite a lot about OpenRISC.
Yeah, but the really good thing about this is that you blogged it all though. So it's not like one guy sat at his desk for a month in a company and then presented it to his boss. You blogged it all, so it's bloody useful.
That was I mean, I love writing stuff like this. I I mean, I would never write a normal book, but writing this technical stuff. And writing it in a way that, I mean, really concentrating on not leaving out anything, because you read so many descriptions, technical descriptions, where people just, first of all, they start out with a level thinking they know you know a lot of things already. My idea was that you don't know anything about, okay, you know something, but you don't know that much. You have to really start from scratch and walk through everything. I don't leave out this important thing that people sometimes leave out. Oh, that's something. He understands this, but you leave out that, and then you're just lost. So that was my idea, just trying to cover everything. So what did I find out? The advantages for a newbie with OpenRISC. Yeah, I mean, it's great. It's free to use. It's just download and use. I mean, compared to use Xilinx or Altera and stuff, it's great. Open source. The open course website, yeah, it's also a little bit messy, but it's a lot of information there. But we'll come to the disadvantages later on. I mean, it's great to have this community with a lot of helpful people. I mean, I talked to Stefan, I talked to Julius, I talked to a lot of people when I ran into problems. And I used the OpenRISC forum a lot, and I subscribed to the mailing list and got a lot of information there. And of course, it's great that you not have to use Xilinx, so you don't have to use Altera. You can actually use whatever ASIC, FPGA vendor you like. So these are the advantages. Okay. What did I find for disadvantages? Yeah, when you just start as a newbie, there is no obvious starting point. Where do you start? I mean, I went into the wiki. I mean, you get lost there. You really get lost there. You don't know where to start.
I think there is one now.
Yeah, no, but and this, I mean, this new how to get started guide. I mean, just telling you, begin here, do this, this, and this.
Well, that's what you've done, right?
Yeah, no. Of course, there is. I mean, there are. Yeah, you could say there are few boards really supported. I mean, there aren't that many boards. That's for sure. That you can just take and use. I mean, you run into problems with a lot of different things, like debugging, for example. The main problem I had was fixing the debugging.
Yeah.
The debugging, I mean, maybe if you read my blog, you find out there how I have to build that special connector to the programming interface and got it working. It was fun, but maybe not what you should spend time on. But no, it works. It's there. It's documented. So there are a lot of web links not updated. I mean, if you try to download a tool chain, that web link didn't work, for example. Documentation, this mixture of all the new and you don't really know if you're looking at the news or old stuff. So there probably needs some cleaning. The next one is maybe a bit more, yeah. Maybe not what to say, but from following the mailing lists, you see there are a lot of discussion about how do we fix these instructions, how do we remove that delay slot, how do we, and you can, I mean, it goes on forever, right?
I don't see how this is a disadvantage.
You're so interested in just going into these details. I mean, fixing documentation, streamlining this boring stuff.
Isn't that a generic issue, though, with any project, any community like this? The open source projects that have good streamlining and documentation tend to be those that are more mature, where you have big corporate interests. You know, if you look at GCC, you've got lots of people at Google and Red Hat whose jobs depend on this being good, and Google and Red Hat pay them to make sure the documentation is done properly. With OpenRISC, we're still earlier in the cycle. What?
Basically took until Cygnus before it was that good.
Yeah. I mean,
but it's also the problem with people like us. We don't really like writing documentation.
Well, it's important to know that that's a disadvantage.
Oh yes.
It's on the list.
It's good. It's on the list.
The ultimate solution is to get more commercial interest in OpenRISC. But I think we could do something about it before we did that.
Sure, yeah, I'm all for encouraging fixing it. It's just, it's not the first project I've heard the complaint about.
Okay, yeah, well, it would be nice to have more. Okay, you still need this FPGA vendor design kit, but of course, for example, for this board, I just used free ICE would make it. So maybe not a problem, but yeah, you have to live with it. So to finish up here, what have I learned from my blogs? Yeah, I learned a lot of things. I learned all about these 4 soft processors, which was interesting, and how to work with boards. I mean, writing C programs, yeah, it's fun. I've done that a lot before, but writing maybe more dedicated.